using an IDS and deep learning with SDN. SDN, that is considered a new technology, new generation of networking. So SDN is abbreviation for software-defined networking that give us a promised solution to change the traditional of networking and make more flexible and controllable. And SDN, that is depending on centralized controller respect. So all the task through the SDN that is made through the controller. So controller consider the brain of the whole networking, and if the controller affecting by attack, that will be leading to destroy the whole of networking. So provided the security for for controller is considered a critical issue and extremely important for authors. And due the side of controller and network side, NIDS, network intrusion detection system, will be efficient and effectively to provide this security. Also, deep learning with NIDS method is recently getting the attract and attention of authors to employ in their research, and to pilot system classification using deep learning with NIDS for SDN is considered significant method to classification the attack. Also, the big problem for authors, he apply deep learning in their research. So our aim of study is, and big problem is try to getting the high result in evaluation matrices and several evaluation matrices, especially accuracy. But before going to clarify the authors using deep learning, you must mention the drawback of traditional machine learning. So the drawback of traditional machine learning is unable to dealing with big data, and if dealing with big data, that is not get for us good performance, and performance that is considered very important because our approach will be applied in the future in real-time system. Also, the researcher that is apply deep learning in deep learning with NIDS for SDN, that is apply just single classifier, and this single classifier that just apply on evaluation on just single evaluation matrices. So boiled NIDS system on using just single deep learning classifier and evaluation this single classifier on just single evaluation matrices, that not will be leading to boiled system classification on attack that is identify the attack with high reliable and getting for us high accuracy. Also, our approach will be applied SDN and IDS in real time. So the performance that is considered very important and try to getting the high accuracy. Also, our aim of study will be applied deep learning with NIDS for software-defined networking. So in in this study, we will apply an evaluation to apply NIDS with deep learning for SDN for software-defined networking, and try to reach the best result in several evaluation matrices such and especially accuracy. Also, our aim of study in this approach will be using 5 deep learning classifier: DNN, CNN, RNN, GRU, LSTM, and apply this 5 deep learning classifier on NSLKDD dataset to boil system classification of attack. Also, our approach will be using feature selection to select the best features to try our deep learning classifier and try to make the training of classifier very fast. Our approach will be applied in real-time system and consider the performance is a critical issue. And also, we'll try to using a little of layer inside the deep learning classifier to getting the high performance. Also, the last aim of study will be evaluation our deep learning classifier in several matrices evaluations such as accuracy and precision with recall and F1 score with row curve and confusion matrices. Our related work will be clarified in this table. But before going to clarify this table, and needed to mention that some authors employ NIDS with deep learning, and a little of a study employed the NIDS with deep learning for software-defined networking, and this consider the aim of a study will emphasize on this area. So we'll start from 2015, authors using NSLKD dataset with 2 deep learning classifier, STL abbreviation for self-taught learning, and SMR SMR abbreviation for self-max regression, and getting for STL is accuracy is 88% and accuracy for SMR is 79%. And will be started from 2016 authors using NSLKD dataset and apply on binary classification for boiler system classification of deep learning, and using in this study just single classifier deep learning and getting low accuracy is 75. So our study emphasis on to optimization this study. And in 2017 authors using NSLKD dataset with hybrid approach deep learning CNN RNN and getting accuracy is 83%. And in 2018 the same authors in 2016, that is authors using NSLKD dataset with hybrid approach GRU from GRU RNN and getting the accuracy is 80-90%. And in 2019 authors apply previous dataset, previous version of dataset is KDD cube 99 apply on convolutional neural network, and the approach that will be detect and bullet to detect the unknown types of attacks. And in 2020 authors employ NSLKD dataset with apply on several deep learning classifier, recurrent neural network, and long short-term memory, and getting for RNN is accuracy 90% and for LSTM is 96%. And in 2021 okay, authors apply an SLKD dataset apply on deep neural network and getting accuracy is 95%. And lastly, in 2022, authors using a new types of dataset is in SDN and apply on convolutional neural network and getting the 96.4. Before to go on to next slide, we need to mention that is a list of study employed NIDS with deep learning for software-defined networking. That is considered the area of my working to getting the new approach. Okay, so this slide, that's our methodology emphasis on it. So in the right slide we can see in right slide that's considered the area and architect of SDN. That's architect of SDN controller from controller plane and data plane. That's considered open flow switch, and that is not considered our working that is clarified in left slide. So we'll be started from an SLKD dataset. Will our approach employ it, and then we'll be going to first step of pre-processing is numericalization using one-hot encoding to change the type of data from numerical size from categorical type to numerical types. And then we'll be going to next step of pre-processing step is normalization using the standard scalar to make all shape in the same context. And after that we'll be going to our contribution that is done in pre-processing data using feature selection to select the best feature, that is training our classifier to make the training is very fast and avoiding misleading fraud. And after that we'll be going to last step is splitting data, and our splitting is between 75 default way for training and testing is 25. And after that we'll be going to steps of evaluation using 5 deep learning classifier, and after that is lastly going to steps of evaluation using different evaluation matrices to produce our approach network intrusion detection system deep learning module. And our dataset will be employed an SLKD dataset. An SLKD dataset that is considered developed to KDD cube 99. Also an SLKD dataset that is considered most important and commonly used by author due the size of this dataset is considered the reasonable size, and our NSLKD dataset contain the 41 number of features and contain the 38 numerical features and the 3 categorical features. NSLKD dataset is contain 1025 per 25.973 total as a total of an instance, and also an SLKD dataset contains several types of attacks such as Proby attack or DDoS attack or so on. Also, our NSLKD dataset contain attack and normal as a target feature distribution, and also our approach will be emphasis on binary classification between attack or normal. So So this slide that's clarified 41 feature and total number of features in NSLK dataset, and consider the first 3 features as categorical features. Then we'll be going to the first step of data set pre-processing. Then we can see in this slide using one hot encoding to change the 3 features in our dataset protocol type and service and flag that must be transformed to numerical features, and using one hot encoding to be able the data during with classifier. So this table that's clarified protocol type is that is features and transform. We can see do you have different two types of data instance. So we have just TCP and UDP. You must have 2 columns, and the first column is emphasis for TCP. You must put 1 value for each TCP, and for UDP must 1 value for each UDP. Next step is normalization using standard scaler. So normalization is considered significant method that is applied to speed, to make the speed of running classifier is high speed and make the all shape of data in the same context, so we can see the data after applied standard scaler. And then consider this slide, consider our contribution that is done after applied data regularization using feature selection, using statistical tool Pearson correlation coefficient. So we must threshold value 0.5 and getting the 41 features from our NSLK dataset, and each features have more than 0.5 that's selecting. After apply Pearson correlation coefficient, we select 9 features from 38 numerical features in our dataset. This slide that's clarified 12 features extracted from 41 will be applied on 5 deep learning classifier. In this slide, I clarify the 5 deep learning classifiers. So we'll start from DNN is abbreviation for deep neural network. We can see using 3 layers from dense and 1 layer from flatten, 2 layers from dropout, using to avoid overfitting during the training our classifier, and using sigmoid for activation function, Adam for optimization function, binary cross entropy as losses function, and to output applied due. Our approach will be emphasis on binary classification, and number of epoch is 100. RNN is also considered types of deep artificial neural network, that is emphasis on pre-processing time series type of data. So we can see using 2 layers from simple RNN, 1 layer from dense, 2 layers from dropout, and the rest of tuning parameter is using the same in our classifier. And next slide that's clarified GRU and LSTM is considered the type of RNN that is invited to solve a problem of gradient vanishing. So GRU and LSTM is emphasis pre-processing type of data in sequence nodes. So we're using 1 layer from GRU, 1 layer from dense, and 1 layer from dropout, and related the LSTM is abbreviation for long short-term memory. We're using 1 layer from LSTM, 1 layer from dense, and 2 layer from dropout. We can see in our 5 deep learning classifier is try to using a little of bit of layer to make our approach is simplicity. That is very important to boiler system classification with high performance. CNN is abbreviation for convolutional neural network. That is considered also types of artificial neural network and powerful, and emphasis to pre-processing the data in pixel shape. So we can see using 4 layer from conv 1D, and 2 layer from dense, and 1 layer from flatten, 1 layer from dropout, 2 layers from max point, selecting max data from symbol data and from feature map. And we can see in related parameter tuning, we also just add ReLU inside the dense layer. We can see configuration clarified in this slide, configuration environment related to the environment we applied on it, and the deep learning library and type of programming language we applied. Related to accuracy, first matrices evaluation, and very important is accuracy. We can see in this chart and this table, CNN is harvesting the high result compared to another classifier in our approach with value 98.6%, following by deep neural network is 98.5%. And relating the precision, we can see the CNN is also harvesting the high result with value is 98.4 is 90, and following by DNN is 98.3%. And related the recall evaluation for classifier, we can see the RNN is harvesting the high result is 99.0, following by CNN is 99.9%. Relating the F1 score evaluation matrices, we can see also in this evaluation matrices, CNN is harvesting the high result is 98.7, following by DNN is 98.6. Row curve is also considered the important evaluation matrices that is using sensitivity and specificity where we applied, and that is mean we depending on true positive rate. We can see the CNN and DNN is getting the same result is 99.8, and RNN with LSTM is also getting the same result 99.7, and GRU lastly is getting the result is 99.6. Confusion matrix, when we mention the confusion matrix, that we must emphasize to getting the high result from true positive and true negative, and try to make a lower value from false negative, false positive. So we can see in our approach that is getting the CNN harvesting the high result, following by DNN, and related the true negative is getting the high result for RNN, following by CNN, and false positive is tried to get the lower value, and we can see the CNN is harvesting the lower value, that mean is burst, and RNN is getting the lower value, false and false negative parameter matrices evaluation. In this slide, we compare our study, our matrice, our deep learning classifier with another or related study. So we can see DNN is harvesting the best result in DNN, or RNN is also getting the high result, and LSTM that is getting the high result when we compare with LCNN and GRU. We can conclusion our working using 5 deep learning classifier for classification the attack in NIDS for SDN. Our approach evaluation not just single classifier matrices, but evaluation on different matrices evaluation. Our contribution that is done using feature selection to select best feature for training our classifier, and try to use a little of layer inside deep neural net, deep learning classifier to getting the high performance, and our approach will be emphasis on applied in real-time system. Our approach is emphasis on simplicity in classifier. That's considered very important. Our approach will be using just binary classification result of a classifier is compared each other, and also combined with related studies. So we can see CNN in our approach that is harvesting the best result in most evaluation matrices, and another classifier is also achieved good result. Our approach that is try to demonstrate the possibility to apply deep learning with NIDS for software-defined networking in the future with high efficiency. See that is some future work evaluation. Our approach not just single dataset. We can using our evaluation our 5 deep learning classifier on more than dataset. And hybrid approach deep learning must be, maybe using in future work, and employ our approach to classify the just types of attacks such as DDoS or probe attacks. Also evaluation NIDS inside the SDN environment to measure the performance and accuracy. We plan to apply our classifier in different areas such as blockchain or cloud or Internet of Things. And if you apply deep learning with using NIDS for blockchain, that's considered the hot topic will be applied, inshallah. Also, our approach we published and getting the letter of acceptance in international conference on machine learning and application. That is conference will be held in 25 and 26 in Copenhagen at Denmark in June. So thank you, dear professor. Thank you for listening, for your effort, for time, dear professors. I hope if you have any question, I am ready, and also thank you. Many thanks. Thank you, dear professor. Appreciate it.
Do you have a question from me?
Yeah, thank you very much for your presentation, first of all. What was your name?
My name is Mahmoud Radi Hadi.
Okay, Mahmoud, your presentation is well, but you make the audience sleep. You have to
one time, not I and
and you are the slowest one today. I'm just joking, of course.
Okay,
Thank you very much. What was the? I heard that I understand that you have a publication.
yes.
In a conference. Adnan, I'm asking the same question to you.
Okay.
Does this work have a potential for journal paper?
Yes, we'll publish in journal paper, inshallah. So we're working on it.
I'm asking to Dr. Adnan.
Yeah, Hujam, yes, it is almost to publishing paper.
Inshallah. Okay.
Full paper,
Okay.
inshallah.
That's good. That's good. Mashallah. Okay.
Full paper and publish, and the conference promised us to publish in journal.
Okay. Yani finally you are going to publish a journal paper, I think.
Okay. Yes.
Okay. The second question, Michael, what was your main contribution? Just one sentence in this thesis. Just one sentence.
Okay. I will try. Our contribution is try to boil it system classification, system
to the literature, of course. I mean, what is your contribution to the literature? Compared with the previous work.
You'll see or what you did.
Okay, evaluation.
When you listen to me, what is your main contribution when you compared with the same areas? I mean, similar works in the literature. What's your difference? Just one sentence. State one sentence.
I understand. Our contribution is using just more than one classifier, deep learning classifier.
In other words, in other sentence, what is the originality of this work? Just one. I mean, these are all the same questions.
Okay. Okay, I will explain.
This Arab character translate automatically.
Victor, are you hear me?
Yes.
Okay. Contribution using more than deep learning classifier to classification of attack inside SDN with high accuracy compared to the related study. Okay. That is our contribution using 5 deep learning.
He increased the accuracy with simple modules, and he used more than classifier, 5 classifiers.
Okay.
All these classifiers gain good accuracy.
Okay.
So I think that's. Can you add more?
Yeah. And also using feature selection to make the performance of deep learning classifier is very fast. And fast is simple.
Where did you get your BS degree from?
PhD?
No, where did you get your bachelor's degree from?
In Baghdad. University of Iraq.
Iraq.
In 2019. In 2019.
Okay, in Iraq? You mean in Iraq?
Yes.
Okay. Thank you very much. I'm satisfied. That's no more questions.
Okay, thank you. I appreciate it, Professor.
Thank you, Hujam.
No problem, Adnan. Well, will I going to sign it or something?
Here with us, Dr. Farhat. He knows you.
Okay. Adnan, will I going to sign something?
Hocam merhaba.
Merhaba Ferhat. Ben soracaktım. Will I going to sign something, Adnan?
No, hocam. Thank you.
Okay.
I will communicate with you later. Hocam, I will communicate later and I will call you.
Okay. I want Adnan, I want all these 3 presentations and including their thesis, please. Okay?
Yes, I will send everything. I will send WhatsApp for you.
Yeah, and if possible, the hard copy of the thesis is okay for me.
Okay, it is ready. Hard copy, it will be better. I will
Okay.
to Ankara.
If it is not a difficult job for you, I mean, for the students, if it is not a difficult task, I want both soft copy and hard copy.
Okay, hocam, I have a hard copy for both, for all of them, and I will, when I come to Ankara tomorrow, inshallah, or 2 days, I will bring to it.
Okay, okay. Thank you very much, Adnan. Thank you very much.
Profesör.
Hocam nasılsınız?
İyiyim valla, Ferhat, seni sormalı.
Çok şükür hocam. Biz de iyiyiz. İyi gördüm hocam sizi. Geçen bir uğradım ama
Yalnız ses düzeniniz çok kötü ha.
doğrudur hocam.
Ay
İyi yaşayın hocam.
teşekkür ederim, sen de abi. İlk sunucu çok kötüydü. Ses yankı yapıyordu, gidiyordu, geliyordu, felaketti yani, ama neyse, bunlar biraz daha iyiydi. Sen dinledin mi? Ben seni göremedim ama.
Hocam ben dinledim, buradayım. Adnan hocam kamerası kapalı ama şöyle kendimi öğrenci kamerasına göstereyim.
Ya.
Anladım, tamam. Ama ses görülmüyor. Ses çok ses iyi gelmiyor ama anlıyorum gene de.
Hocam belki toplantı yaptığım dolana kaynaklanıyor olabilir.
Tamam, önemli değil. Tamam, teşekkür ediyorum.
Tamam. Hocam müsaadeniz olursa birkaç soru da ben sormak istiyorum.
Anlayamadım Ferhat.
Hocam müsaadeniz olursa birkaç soru da ben sormak istiyorum.
Tabii ki. Buyurun hocam. Ne demek yani?
Tamam hocam. Mahmut, firstly, thank you for your good presentation.
Thank you so much.
In your presentation, you said that traditional machine learning methods failed. Big data. Why?
Because the deep and the speed the conception the high on from the source of the computer. That is why the deep learning
Bıktım. Dur bir dakika.
Kaç tane fatura vardı şunlar?
Tamam, onu ben bir şurada. Bir dakika. Niye ses gitmiş ya? Pardon abi. Bir dakika. Ya Ferhat, ses gelmiyor. Ben sen ne duyduğunu öğrenmek istiyorum ama duymak istiyorum ama sesi kestiler, bizi attılar dışarı.
Mikrofon kapalı mı? Hocam öğrenci mikrofonu kapatmış da.
Aferin, iyi yapmış.
Tamam.
Ne sordun, bir de ne öğrendin? Bakayım ben de duyayım. Oldu mu?
Tamam. Ben şeyleri sorular olmasını gönderirim. Ya da şöyle şunu sordum. İlk soru şuydu. Genetikten makine öğrenmesi yönde. Hocam duyuyor musunuz?
Duyuluyor. Yani ilk şeyde bu traditional metotlar fail oluyor dedin. Onu neden öyle olduğunu sordun. Onu duydum. Ondan sonra hiçbir şey duymadım.
Hocam daha sonra iki tane kullandıkları modelde iki tane çıkış vardı. Ama binary classification yapılmıştı. Dolayısıyla niye iki çıkış kullandıklarını sordum. Adem Hoca da orada one hot encoding yaptıklarından dolayı böyle bir şey olduğunu söyledi.
Ha.
Sonrasında şu anki cevaptan sonra da sistemin gerçek zaman olarak çalışıp çalışamayacağını sordum. Onu dolaylı olarak doğru olduğunu öğrendim. Çünkü model, temel bir model. O yüzden gerçekten dediler. Şimdi devam ediyorum. Birkaç soru daha var.
Tamam. Teşekkür ederim.
Rica ederim hocam. Is the dataset balanced or unbalanced?
Of course, balanced. Balanced. We can see the different types of attacks, but the first reason to using our dataset is have a reasonable size, and after to make a survey that is getting and see more than search emphasis to using this dataset. This dataset, our dataset, and SLKD dataset, no contain the null value or redundant value that is after applied by cybersecurity research Canadian laboratory in New Cross University.
Okay. Why I ask? Because your condition matrix. Okay. This is not matrix. Yes.
No. This true positive.
These are graphics. Not
Yes. Okay. Do you have five?
So if you show as matrix like.
Okay. I have result. If you need to see my confusion matrix, okay, you can see.
For one is five. Because you have five classifiers. So this, which classifier for?
Okay. This is for CNN convolution. CNN. Okay. This, and if you need it for getting for.
Make it larger.
Okay.
Zoom.
Okay, zoom. Okay, we can see. For DNN.
What is the accuracy of?
Try to getting the true positive high value, try and emphasis to getting the lowest value. So I getting the using this chart in our BBT because we have 5 different classifier and try to make the compare between our result.
Is this the final one, the last one, or just intermediate?
Yes.
The last you obtained. The last result you obtained.
Yes, the last result. Yes, it's same. But to make difference between the compare between the result of our classifier.
Okay. Last two questions.
Yes.
Please, in your presentation.
Okay. Yes.
Open feature selection.
Feature selection.
Slide.
Feature selection. Okay. Feature selection method.
Yes, previous.
What?
Previous.
Previous.
Yes.
Previous? Previous one. Data normalization.
Yes.
Okay.
Normalization is significant method to speed running because
Okay.
make data in same context. How?
The speeding, because if you have different between data, because if you have data such as, and different data is 8 or 100.
In training selection or testing. And normalization make it speedy, right?
Yes, speedy the training, because the data is the same context, so we can different data between the going from high data and lower data. That is the considered the significant method. So more than one research paper I read it that is considered the normalization is significant method must be applied in these types of data set.
Okay. You have lots of features, but
yes,
you select some.
Yes, you select just have correlation with target features, have more than 0.5. We made just 0.5 a threshold. Okay.
We make statistical method, Pearson correlation coefficient, which is by this method make the feature selection. So just this SDN.
We made using Pearson correlation coefficient that's considered significant method, statistical tool to apply. When we make 0.5 from 41 features, we have total number of 41 features in our select. So every feature in our dataset and SLTD dataset must have more 0.5 correlation. So first is more than 0.57 and then going more than 5, that is selecting to be correlation with the target feature. That's our approach to this emphasis on it.
Okay. So your metric is correlation. Is this contribution here in this because use this method and reduce the features, that's why make the performance high and low there. And this statistical method reduce the number of features. Yes. From 43 or 41?
From
41 to 12. Okay. And that's why we didn't need any more complex classifier.
And so classifier to add layer or change layer in grade. Okay.
It's enough for me. Just one question. It's about on our quiz about did you apply any other feature selection method?
No. Just applied feature Pearson correlation coefficient. We have another. We have just random forest. We have tool is the name is name random forest tool. We have to select and selecting the features from dataset. We have also correlation of or relation to feature. But I using Pearson correlation coefficient. It is not needed to boil it random forest and after random forest apply the voiding tool in random forest. But this is very complex. I'm using just simple code that's selecting the threshold value and we can see and read about it. Okay. Thank you so much.
Thank you, Mahmoud.
Thank you.
Thank you, John, for your attendance.
Thank you for notes.
For your contribution in our work and this work.
Highly appreciated,
Professor. If you have any else, you can write by PDF or I will write PDF by on the Word file.
Okay.
Did you send Word file for us?
No, I will send.
Send the Word file.
Okay. I send just thesis, just.
PDF?
PDF, yes.
PDF. I can write, okay, you can write. Okay. I have some notes on PDF. I will update and send.
Okay, no
Okay, yeah, send it for me or for
Okay. Thank you.
Thank you, John.
Thank you.
Appreciate it. Good work. So, taking the forms, I will come to you. Okay. Tomorrow you will be? Tomorrow, yes, I will be here. Okay, so maybe I will finish and check it.
Fatih Hocam, teşekkür ederim for your attendance. Thank you, appreciate it. See you, inshallah.
Take care. Thank you.
Hocam, I will visit you to bring your hard copy and take your signature in Ankara.
Thank you very much. No problem.
Thank you. Bye bye.
Hocam iyi günler.
İyi günler. Kolay gelsin.